it's great that so many people have come to listen to hear about the different possibilities opened by the new high-throughput screening and chemistry facilities. And so in this first session, we've got this series of talks about the different facilities and by some of us who've been using them already. And so we're going to open with a 20-minute talk from Karan, who's head of the High-Throughput Screening facility, and who's going to just give you an overview of some of the facilities available here in the Berry Center. Thank you.
Great, thanks, Chris. Good morning, and thanks for coming out to the High-Throughput Screening Symposium today. I'm going to introduce you to the High-Throughput Screening core facility located on the Medical Center campus here at Columbia. Before we start, I want to take a moment and acknowledge the 3 funding agencies which played the key role in restarting the High-Throughput Screening Center on the campus. NISTEM, the Helmsley Trust, and Urban Cancer Center. And I'm contractually obligated to tell you that 50% of all assays run in the screening center are co-sponsored by NISTEM and should be stem cell based. So all you stem cell users, come talk to us. We're definitely excited to work with you. Okay, so the field of high-throughput screening is extremely vast. It covers manipulating gene function using RNA interference, increasing gene function using cDNA libraries, and altering protein function or modulating protein function using small molecules. Now, the end goal of all of this is to better understand the systems that you're studying. So all of these have in common the fact that they're all designed to dissect systems and give you information on a minute level. Whether your end goal is to develop new drugs or your end goal is just to better understand pathways in a particular cell line or disease or whatever it is that you're interested in studying. This is a small slide, but it's actually the most important slide. Okay, because what I'm trying to impart to you is what you need in order to gain access to high-throughput screening. Okay, now it starts with an idea. It starts with something that you guys are interested in studying, and when it comes into the center, every project comes in at a different and unique state. Some people come in with totally validated assays, and it's simply a matter of us taking those assays, fitting them into our automation, and running those assays in throughput. Some people have no idea what an assay is, don't know how to design one, and so we work together, we sit down, and we talk about the fundamentals of assay design, and we design an assay that's right for that system. So there is no wrong answer. There is no point where you should enter. You should enter as soon as you think you have an idea, and we can talk about it. Fundamentally, there are 2 very basic assay types. It could either be a biochemical or protein-based assay or a cellular assay. In the center, we have state-of-the-art equipment so that we can handle either cellular assays in a high-throughput format or obviously a biochemical assay. So it's really not even an issue. Again, I think that the main point I want to stress is that if you have an idea, you can work with us in the center, and we will help to develop an assay with you. Now, once we have an idea, we work on an assay, we develop it, we'll validate it using some positive controls. We'll then go forward and start to run our initial experiments. These are pilot screens. The pilot screens are typically relatively small, 2,000 to 3,000 or so compounds, and this is really the initial stress test of that assay in the automation. And what we want to find out at this point is, first off, do the plate-based statistics still hold up? So does it give us reproducible assays? Does it give us good Z primes? The other thing is we really need to test that our automation can handle the assay. So a lot of times assays, depending on, especially cellular-based assays, can be complex. There's a lot of different liquid handling steps. Material has to move from one place to another. This is our first chance to sort of do that in mass and make sure that there's no hang-ups that we didn't foresee during the assay development stages. And also, important, I'll get back to this later, every assay that we develop, we're developing custom data analysis tools for you guys, the end users, to look at your data, visualize your data. So this is, again, our first chance to sort of roll those out there, get them to you, and let you see the data. And generally what happens is after a pilot screen is over, we'll roll back and have a meeting, we'll talk about the initial results, and we'll make a decision whether to go forward into the large-scale assay or whether we need to go back into development and tweak some things. From the pilot screen, we're going to go on to our primary screen. And that's obviously the large-scale screening. At this point, our diversity library is only 10,000 compounds. This is from Brent Stockwell's lead optimization library. And we are in the process now of building our screening deck. It's going to be about 100,000 compounds. I'll talk about that a little later on also. Now, once the primary assay is over, the work is not done. Okay, this is actually when the work really starts in earnest. The first thing we want to do is we want to confirm that what we screened in the assay will actually re-hit. So that usually involves us rescreening in a high replicate. If possible, we would like to get source material from the primary vendor just to confirm the activity. These are organic compounds, so you do have to make sure that what you thought you screened is what you screened. And I add this here, and this is not applicable for everybody, but whenever possible, we like to help develop secondary assays. And what that is a totally different assay. Usually this is a low throughput assay, but it's a way for you to further narrow down the hits that you got from your primary screen and select the best set of compounds to go forward into other more low throughput assays. Now, what are we? Fundamentally, we are an extremely flexible center. Okay? So we handle assay types of all kinds. There is no assays that, well, there's no assays yet that we've turned away because they're cumbersome or there's something that we can't handle. Our primary importance is running the right assay for you guys. And whatever that is, we'll figure out a way to automate it and run it. We have a wealth of experience in our staff in high-throughput screening. Everybody that's on the staff has been doing high-throughput screening for a long time. So we have a lot of experience in a lot of different assay types. So again, another reason why you should contact us as early as possible. We may have experience in the field that you're interested in or a similar field, and we may be able to either steer you clear or give you some guidance in the beginning steps. Education and training. We love for people to come in and get involved in the high-throughput screen. That doesn't mean we let you run the automation, but we want you to be as proactive as possible with your screens. We want you to have ownership of your screens. We want you to understand the decisions that we're making and why we're making those decisions. So, let me see if I can bird dog my group here. So I want to introduce you to the staff of the High-Throughput Screening Center. Where's Sergey? No? Yeah, great. Okay, so Hai is hiding in the back. So if you have any questions, Hai is a PhD in the Screening Center, and she runs the assay development, assay optimization. So if you have questions later on, feel free to harass her. Sergey, he was here. We saw him earlier. He's also a PhD. Feel free to harass him. And Ron is in the back doing camera work. Ron's the technician and the basic do-all in the lab. I have to have at least one gratuitous automation slide because that's what I do. So what we want is for that if you're interested, right after this symposium's over, we're going to hold an open house in the automation suite so you guys can come over, see the automation. Ron, will it be in motion at noon?
Yes.
It will be in motion at noon, so we have assays going, so you can see it in all its glory. But I think we should point out the centerpiece here, which is the Cell Explorer. And that's what allows us to run our cell-based assays in a hands-free, high-throughput setting. It's a robotic, basically it's just a robotic arm with different tools around it that allow us to run all these different assay types. And of course, we also want to mention our in-cell which allows access to high content screening. So for a lot of our screens now, we're seeing more and more migration away from a reader-based assays and towards high content screening. Okay, so this is probably the first time that this has been publicly announced at Columbia. We recently closed a negotiation with Sigma Aldrich to become the primary distributor, if you want to say that, of clones from them on campus. And what that means is that we have access to shRNA clones at an extremely discounted price. It's the clone plus the glycerol stock. And what the center does is we take a copy of that glycerol stock and we archive it. So there'll forever be a backup copy of every clone that's ordered at the university in the center. And you can see the prices. It really depends on the economy of scale. So we really promote and we try ourselves to pool orders together so that we can get the maximal discount possible. But we have not bought any clones for $54 yet. Most of all of our clones have been at $38, $38.50. And if you have any questions or you're interested in getting more information, you can actually just email shRNA@columbia.edu, and we'll get you all the information you need and get started. Okay, so I'm going to try to wrap up here with some of the innovation that we've put forward in the last year. The first thing that we've done is put together this Columbia Cell Line Encyclopedia. That's 850. Is that a hint? 850 cancer cell lines that we've collected from all around the world. And those cell lines are available to researchers who are collaborating with the center. So again, if you have any questions, just feel free to stop by and ask us. The diversity library. So this, obviously the focal point of any high-throughput screening center is its screening deck. So we've been working with Brent Stockwell's group, trying to design some tools to better annotate small molecule libraries. And as I said before, we're looking at about 100,000, that shouldn't say bioactive, I'm sorry, 100,000 diversity compounds by the end of the year is our goal. What's that?
He said the goal is a collection of...
Yeah, that was to air. Yeah, it's just diversity library. It's not going to be... so what we're doing is we're using physiochemical properties to annotate and select compounds from commercial vendors. And so we're using basically all of the traditional algorithms that are available for doing this. And we're building our own sort of set of internal tools so that we can, I don't want to say commercialize it, but basically create our own internal tool chest, if you will, for taking large sets of compound data and weeding it away to our highest potential quality. Right? Diversity libraries are inherently, like the lottery. But what you want to do is enrich your best chance for hits. And the last thing I want to talk about on the innovation front is the cheminformatics. So obviously, high-throughput screening is an information-rich science. So one of the most difficult things for us is delivering that information to you. And so what we've done is we've purchased a commercial software called Pipeline Pilot that delivers the data to end users through a web browser portal. And so we can work with you and create data visualization tools that you have access to on your lab computer. So again, it's this idea of empowering you with your data. Now, if that's something you're not interested in, we can turn it around and just create reports for you and spit out the data. They're very customizable and they're tailored to whatever the end user really wants. So, I've talked a lot about high-throughput screening, so I'm going to kind of skip over this first part, because I think you understand some of the steps that take place in designing and executing a high-throughput screen. Obviously, a lot of these steps can be similarly applied to RNA interference experiments. But I also want to say, even if you don't want to use our automation or utilize our automation to run these assays, all of these materials are available to you, especially the shRNA. So talk to us, and we can work that out. You don't have to run a high-throughput screen to use the high-throughput screening core facility, right? We have instruments that are open access. Currently, the InCell, so our high-content instrument, is open access. You have to get trained first, but it is an instrument that you can, sign up and use. We recently purchased this HP digital dispenser, which is great for doing compound dilution experiments. It's very easy to use, and we plan on making that an open access instrument too. And our goal is to take one of our plate readers and create an open access plate reader facility. So if anybody has an assay that they're running that's not high throughput, but they just need a plate reader to run it, we want to have a little section carved away in the center where people can access a plate reader. Now I think, I got to wrap up here, but I think what you'll see in all the talks that come is the power that you have available to you here as part of this high throughput chemistry and high throughput core facility. The power of computational biology, chemical biology, medicinal chemistry, and stem cell research. Lydia's going to get that. So I think this series of symposium really highlights all of that that's available to you. And finally, I want to invite everybody back to Rossberry 510. After the talk, we're going to have an open house, but if you have any questions at any time, you can always contact screening@columbia.edu, and we'll set up a time, we'll sit down and we'll talk. Questions?